Hi, I'm Jimmy, aka Perceptes. If you're new to the channel, welcome. I share electronic music performances and educational videos on music production with an emphasis on hardware and modular synthesis. In this video, we're going to look at a small but complete Euro rack modular setup for making drones and having fun with sound design. Modular setups can get very big and very expensive, but there's plenty of fun to be had with a smaller system, as long as you have a goal in mind and a cohesive plan for which modules to use together and how. First, we'll cover the goal for the system. Then, we'll discuss what each of the modules do and what role they play in achieving that goal. And then, of course, we'll get to patching and making some cool sounds. If this sounds good to you, stick around. In case you're not familiar, a drone is an element of music where there's a single note or a single chord that just holds for a really long time, very often through the entire piece of music. While that may sound like it would be boring, there's actually a lot of ways to make a drone interesting, like having a bunch of other instruments that sort of move in relation to the drone and sort of recontextualize the sound. And in electronic music, it's very suitable because a lot of what we do is based on changing the timbre of sounds through processing, filtering, effects, that kind of thing. So it's very suited to modular and very popular to create something where you're not doing pitch sequencing, you've just got a single sound that goes on and you're focused on making timbral changes to keep it interesting. So that's the goal here. And in addition to just being able to play a note for a long time with some timbral controls, we also want a lot of modulation so that we can patch up control signals that will change the sound automatically in interesting ways that don't repeat in a very obvious way. So it's kind of constantly moving and shifting and morphing in a sort of organic way that doesn't get boring even over long periods of time. In addition to patched modulation, we also want some options for performability so that while the patched modulation in the drone is going, we can do something with our hands to further shape and morph the sound. So all of the modules in this small setup are working towards that goal. The most important part of our setup, of course, are the sound sources, the oscillators. So we're using two oscillators in combination here, Toros Iteritas Alea and Ona. Toros is a module from Noise Engineering, and it uses their Alea platform, which is a really cool thing where you can buy one of the modules in the Alea series, and then you can flash the different firmwares from the Alea series onto the module that you bought, regardless of which one you bought. So you may actually already have one of these, especially Basimilus Iteritas, which is very popular. This particular one I bought as a Manus Iteritas, which is kind of like an industrial voice, but I have the Toros firmware flashed onto it, and I'm using the little overlay panel they sell that changes the labels so you can know exactly what all the controls do. Ona from Nano Modules is a fairly straightforward analog oscillator. It's got direct outputs for the core waveforms that we're used to in an analog oscillator, a sine, triangle, a saw, and a square wave with pulse width modulation. And then it's also got a sub-octave and 2-octave down sub-octave oscillator, as well as two complex oscillators that are created by combining a triangle wave with a pulse wave and a saw wave with a pulse wave. And all of these outputs are available simultaneously. Let's talk a little bit more about Toros Iteritas Alea to explain kind of how this works. It's really designed for drones, and so it's perfect for this application. It's a module that has actually multiple internal oscillators, either 3 or 4, depending on which of the algorithms you choose with this top switch. But the basic idea is that each of the internal oscillators has a frequency offset that can sort of detune that oscillator from the master pitch. And then each internal oscillator also has a blend control. When turned fully counterclockwise, the audio from that internal oscillator will be sent directly to the audio output, so you can hear it mixed with the other oscillators. And as you turn clockwise, you'll be hearing less of that oscillator, and instead its signal will be used to modulate one of the other oscillators, either the fourth oscillator, which you don't have direct control over, or one of its adjacent neighbors. So we're going to be using this as a base of our sound source that's going to be really shifting a lot in time as those blend controls change and this sort of audio rate modulation between these interrelated oscillators happens. In addition to that main output, there's also a fundamental output, which is just a basic saw wave that's at the pitch that you've tuned all of the oscillators to. And so between these two oscillator modules, we have 10 different oscillator outputs that we can combine and mix in different ways to change the sound. And to that effect, I've included my new module from Vostok Instruments, Hive, which is a 4-channel stereo mixer with pan controls. So we'll be able to patch in whichever oscillator outputs we want into these 3 channels, control the pan either manually or with CV, and send them to a stereo output, which we can then further process. For further sound shaping and effects processing, we've got some additional modules here on the right. Dual Dagger from Shackmat is going to be the filter that we're using. And we're going to send the stereo output of the Hive into the Dual Dagger, and we're going to use this as a bandpass filter. It's got a built-in high pass and a built-in low pass that you can use simultaneously, but you can also link them together to create a variable width bandpass. But before we send the signal directly into Dual Dagger, we're going to send it through the SumDiff, which is a precision adder and subtractor. One of the great applications for this module is that we can use it for mid-side processing. So rather than processing stereo as the left channel and the right channel, what SumDiff will allow us to do is process the center, so the things that are in common between the left and right channels, and the difference, which is things that are in the stereo field but not in common in the center. And this will give us some really interesting effects as we modulate that create effects that you hear only on sort of the outer edges and ones that you only hear in the middle, and we can fluctuate sort of back and forth between those two for some really interesting effects. And then finally, our real effects module here at the end of the chain is Beads from Mutable Instruments, which they call a texture synthesizer, but essentially it's a granular processor. So this takes stereo audio input and it gives you stereo audio output, and it's got its own built-in reverb, which we can apply to the dry signal. And then we can also mix in grains that are created by sampling little tiny bits of the incoming audio and playing those back at different sort of lengths and envelopes in terms of the amplitude change, different pitches, different densities. We can sample from different parts of the recent buffer to get different sounds. We can feedback on itself. It does a lot of things, and this will be a lot of the sort of focus of our sound design. This is also a very effective module because it has built-in modulation with these little trimmers down here that can affect these parameters regardless of whether or not you have an external modulation signal patched into the jacks here. So that's our sort of sound sources, our mixing, our effects processing and filtering. Finally, on the left edge, we have our modulation section. We're using the Oct from DivKit and Instro, which you're probably familiar with already, but it's an 8-channel LFO where the LFO is not synced to a tempo. There's one control that just sets sort of the master rate of all of the LFOs. You can see the lights flashing as faster speeds as I turn this up. These are bipolar triangle waves, and they're tuned relative to each other so that they kind of never land in the same place on a cycle. And as a result, you get this very organic modulation that's very easy to use. You just patch it to where you want, and you're off to the races. And finally, we have Lapsus Os from Noise Engineering, which is a 4-channel attenuator that you can control with sliders. And so we're going to use this to attenuate the signals from Oct because that's a full range modulation signal, and we may not want that degree of modulation for some of these parameters. So this will allow us to bring in the range of those modulation signals for anything that doesn't have a built-in attenuator, and will also allow us some degree of performance because we can change the amount of attenuation on any of those LFOs with these sliders. It's also handy because each of the channels has 2 identical outputs. So for any given LFO that we've patched through one of these channels, we can send it to 2 different destinations elsewhere in our system. Okay, now that we've talked through all the modules and you understand what they all do, let's start patching this up so we can hear what it sounds like and what it's capable of doing. We're going to start with our basic audio chain, and I'm going to patch the sub-octave output from Ona into the first channel of the Hive mixer, and then we're going to patch the stereo output of the mixer into the SumDiff. So we're going to use this for that mid-side processing. We patch into the A and the B inputs, and then we take the addition of those 2 channels, which is the mid content. We send that into the left side of Dual Dagger, and then we take the difference of those 2 channels, which is the side content, send that into the input of the second channel of Dual Dagger. So Dual Dagger is designed for left-right, but it doesn't know the difference. It's essentially just 2 filters. We're going to take the output of Dual Dagger, and we're going to send that back into the C and D section of SumDiff, which is going to take our mid-side channels and recombine them into discrete left and right channels. by sort of reversing the operation that we did above. So we're going to patch out of the C plus D output and the C minus D output. And these two are going to go into the left input and right input of Beads. And you can see that little light flashing there because Beads is now listening to the new incoming audio that's coming in on these jacks. And it's adjusting the gain so that it's not too hot. And I've got the outputs here patched to my mixer. And if we unmute that channel, we should hear something now. There we go. So that's just the sound of the square wave by itself. And we can turn the gain down for now, so we're not listening to that forever. And now we need to decide what we want for the other three channels. So for the second channel, I'm thinking maybe we take the pulse wave at the root octave from Ona and put that into the second channel. And of course, if you don't patch anything into the right jack on any of these channels, it'll normal from left to right. So you'll get a mono signal that's pan center. And then of course you can adjust the panning with this control. Okay, so let's listen to that. And let's maybe offset the panning on this a little to the side to give us some stereo image to start with. Sounds pretty good. And then for our third channel, I think what we'll do is we will use the two complex wave outputs from Ona. So that's a triangle wave mixed with a pulse and a saw wave mixed with a pulse. And we're going to patch those into the left and the right inputs of the third channel of the mixer respectively. So let's listen to that. So we now have got a nice wide stereo sound because we've got two different waveforms on the left and the right side. And then finally, let's patch our real drone oscillator, which is the main output of Toros Teratosaulia, into the left input of the fourth channel. This is just a mono oscillator, so this one we can also pan around, and we'll probably want to automate the panning for this. So let's listen to that. That already sounds really cool. Let's bring in a little bit of reverb on Beads. Okay. Sounds good. Okay, now let's work on some modulation with Toros using Oct. I think what I'm going to do here is, because we only have 4 channels of attenuation, but we have 8 LFOs coming from Oct, I think I'm going to patch 4 of them through the attenuator and leave 4 available unattenuated. And I'm going to patch the right column because these are kind of ordered from fastest to slowest relative to each other. So if we just go down the right column here, then we'll get kind of a nice distribution from fast to slow in terms of LFO speed. And of course, we can change the master speed with that knob. But this will give us kind of a good distribution that we can use for different purposes, and we can attenuate these. And as I said before, we have 2 destinations per channel of attenuation here. So we've got 8 outputs plus an additional 4 outputs. We may not need to use all of this, but it gives us a lot of options, which is part of the nice part about this case's design, is there's a lot of flexibility. But let's take actually 3 of the unattenuated outputs, and let's send those directly into, I'm going to actually go from the slow end here. So I'm going to take the slow end. Let's patch these into the blend control from Toros, and let me actually bring the volume up so we can listen to this. So patching into the blend, and I'm going to set the blend controls at noon because we're giving it bipolar LFO. And as a result, it's going to move the knob both clockwise and counterclockwise from its initial position. So just 3 different speeds of LFO into blend 1, 2, and 3. And then if we detune these oscillators with these frequency knobs, we can go down an octave and up an octave. You hear that slow timbral change there? That's exactly what we want. I think for our last LFO here that we are not attenuating, I'm going to patch that into the pulse width modulation on Ona. because this has a built-in attenuator. And this is cool because Ona's pulse width modulation goes all the way until the pulse is so narrow that you can't hear it, like essentially 100% duty cycle. And so we get these kind of gaps in the sound. And those rests give a little bit of a rhythmic sense to our drone. Of course, we can change the speed of that by changing the speed of the LFO. But I think slow works well here. Okay, for our first attenuated channel, I'm thinking one thing that might be interesting is going to the pitch of Taurus the Teratosilia. So this gives us a little bit of instability. This might be a little bit of too extreme. The other thing we could try doing is maybe modulating just the frequency of the F2 middle oscillator. Then I can bring up the attenuation to let a little bit of that signal through. We don't want to make it too unpleasant to listen to. We just want a little bit of warble in there, kind of a little bit of instability. I think that sounds pretty cool. And then for the other copy of that first signal, let's maybe go into the FM input on Ona. Ona has both linear and exponential frequency modulation. So we can increase the attenuation here. I guess since we're attenuating here, we'll just bring Ona's internal attenuator on FM all the way up. And that'll give us some rich textures. We can also try exponential. Yeah, that's more extreme than we want. Let's stick to linear. Let's bring in a little more reverb, go like to near 50% dry, 50% wet. And let's start playing with the filter. So in the linked mode, when you're using a bandpass, the high pass filter control at the bottom sets the lower bound of the bandpass. So you hear as I turn this up, we'll lose the low end. And the low pass filter control at the top controls essentially the high point of the band. So in combination, this sets the width of the filter. So if I set this maybe at 50%, we get a nice, dark, smooth sound. And I can turn up the resonance to give us some resonant peaks. And now here's the really cool part about using mid-side processing with dual dagger. It's got inputs for detuning the left and the right channels. So if I take one of our signals, let's take the fourth channel, a copy of the fourth channel, and I'm just going to bring the attenuator all the way up so we get the full strength signal. If I put that into, let's say, the low pass input, then it's detuning the cutoff of the bandwidth between the left and the right sides. But remember that our left and right sides, when processed through some diff this way, are actually mid and side. So we're getting multiple resonant peaks that sort of sway back and forth between the middle only and the sides only. It's a very cool sound. We can try taking the third channel of lapsus os, maybe 50% attenuation. Let's stick that into the high pass offset. And this will detune between the mid and the side, the cutoff frequency at the lower end of the band. Okay, let's bring in some of the effects from beads. If I start to turn this knob, that gives us wet-dry mix, and then if I turn the density counterclockwise, we'll start to get grains at a constant rate. And the more I turn this, the more grains we get until we get sort of like a constant pitch. Let's turn up the pitch of the grains so they're really quite audible. So the density will be kind of like the speed of the grains or the amount of time between them. We can change the shape to sort of make them smoother so there's not such a hard attack when a grain is triggered. We can use the size control to affect the length of each grain, like how long it lasts. So you hear that cool kind of warbling effect with the grains as the modulation of the filter moves the resonant peaks in the sound. Let's take another modulation signal from Oct, maybe the second copy of this third channel, and send that into the panning for the fourth channel, which is our torus oscillator. So this will really add a lot of movement because we're now moving our most modulated drone oscillator back and forth in the stereo field, which when processed through some diff is really changing kind of which parts of it are mid and which parts of it are side. And you really hear that kind of swirling circular movement. We can also go more than 50% wet on the reverb in beads to get a really atmospheric kind of sound. Let's maybe bring the pitch of the grains down. And we can start experimenting with modulation on beads. So remember, we don't even need a signal patched into these to get modulation. If I turn to the right slightly on the pitch trimmer, then the pitch of the grains will vary slightly for a little bit of sort of instability while still sounding consonant. We can vary the amplitude envelope that's applied to each grain to make it more or less plucky. And we can vary the size of the grains so that some are shorter and some are longer. And then we can play the rate of the LFO. A little bit of change goes a long way here. We can try doing some more CV modulated panning with one of our free channels from lapsus os. Let's maybe send that into the second pan input, which is our pulse wave. Let's give that a good amount of signal so that it moves a lot in the stereo field. Turning up the resonance is interesting because it does cut some of the bass on oscillators that are fairly low in their tuning, but it also gives you a lot of that beautiful resonance. And I find that the resonance on this filter is very kind of smooth and pleasing. It doesn't get very squelchy and kind of piercing, so it's very suited for this kind of smooth modulated drone. We can also try changing the octave of Ona to give more of a sort of range of frequency, so we have a little bit more high frequency content going into beads. Maybe even another octave. I think both of these work pretty well. And in the higher octave range, we can also try changing our sub-oscillator to 2 octaves down instead of 1 octave down to keep some of that original low end, kind of more of a spread of notes from low to high. Let's decrease the amount of modulation on dual daggers so that we can control it more manually. And we also have the ability on beads to change the sort of sample rate of the audio with this button in the middle. There's 4 different modes of sort of fidelity. We've been operating in the mode that has the highest fidelity but the shortest recording buffer. We can try toggling over to one of the sort of lo-fi versions. I think maybe the 4th one will be the most drastically different. And this reduces the sample rate of both the dry signal that it's passing through as well as of the grains. So a lot more sort of degradation. We can try using our last attenuated output of Lapsus Os for modulating the density. So lots of different sounds that you can make with just this small number of modules. And of course, you know, I've just used 4 of the outputs across the 10 that are available between Taurus and Ona. So any different combination of waves that we mix into the mixer, and wherever we send these modulation signals, we're going to get a very different result. And you could just spend hours experimenting with different sounds. I hope you enjoyed this, and I hope it gave you some ideas about how to put together a small system of your own for some fun droning and sound design. I'm thinking about making this type of small systems video a series. If you'd like to see more videos like this, please leave me a comment and let me know. If you found this video useful, I would greatly appreciate your support on Patreon. You can join for free for updates on new content, or you can chip in a few dollars a month to support my ongoing work in making videos. Patreon subscribers get a bunch of benefits, including high-quality audio downloads for all musical performances on the channel, detailed patch notes for educational videos like this one, sample packs, video requests, full access to Discord, and more. If you want to pick up a small modular case, or any of the modules I'm using here, you can also support my work by purchasing from Perfect Circuit using the link in the video description or the pinned comment. This will earn a small commission for me at no additional cost to you. Thank you so much for watching. I'll see you next time.